A tennis ball thrown horizontally from the top of a water tower lands 20 meters from the base of the tower. If the tennis ball is initially thrown at a velocity of 10 meters per second, A, how high is the water tower, and B, how long does it take the tennis ball to reach the ground? First things first, we do our diagram. We know the projectile is shot from the top at 10 meters per second. We have a height. We know the projectile is going to form this kind of parabolic motion. That's going to give us a range, or a dx, and time is our question. Well, it's one of our questions. So A, how high is the water tower? So H is the question. So now we need to look at the vertical component only. Okay? So we have VI, y, is equal to 0. dy, or H in this question, is the question mark. A is going to be 9.8 meters per second, because we are going to say right and down is positive. VF we don't know, and time we don't know. So now we can't solve this problem because we have two unknowns. So let's go on to B. How long does it take the tennis ball to reach the ground? Well, in this case, we have, when the ball hits the ground, 20 meters away, the Tx is going to equal the Ty, okay? In other words, it's just called time, because this is the time the ball is in the air. It doesn't matter if it's in the horizontal or vertical component, it is the time it's in the air. So let's take a look. Vx, we know, is 10 meters per second. Dx, we know, is 20 meters, because it lands 20 meters from the base. 20 meters. And time is our question. We know our very basic equation, V equals d over t. Convert, t equals d over v, 20 over 10, which equals 2 seconds. We can now plug that into our equation there. Now, let's see what we get. So let's use the equation, d equals v I t plus 1/2 a t squared. We plug our numbers in, we're looking for d. Vi is 0 plus 1/2 9.8 times 2 squared. When we do that, we get a dy, or height, of 19 meters. 3 sig digs, 3 sig digs. So let's say 19.0 meters. That's the height. So now we have our two answers. We have the height, and we have the time. That's obviously the answer to B, and that's the answer to A. An archer shoots at a target 60 meters away. If she shoots at a velocity of 55 meters per second right, from a height of 1.5 meters, A, does the arrow reach the target before striking the ground? And B, what should the archer do to get her next shot on target? So again, let's draw. Your bow and arrow here. Okay. We know the target is 60 meters away. We have a Vx, 55 meters per second. So we need to find the time before the arrow hits the ground. So in this case, we're going to look at the vertical component only, once again, okay? Because like we said, whether it goes like this or straight like this, the timing is going to be the same, okay? So if we focus on the vertical component, we can find out the time it would take for it to hit the ground. So Vi y equals 0. We're going to set right and down as positive. So we know A is 9.8. Distance, that's the height that it shot from, is 1.5 meters, and time is our question. So we're going to use our equation d equals VIT plus 1/2 AT squared. Plug our numbers in, 1.5, that's 0, 1/2, 9.8, t squared. You do the math, you find that t squared equals 0.306, and therefore time equals 0.55 seconds. That is the time it takes for the arrow to hit the ground. Okay. So that's going to be, we'll call that part 1. Okay. Part 2, we have a little bit of information. Okay. We know that the in this case, we need to find the horizontal distance. How far does the arrow travel in 0.55 seconds? Okay. So we know Tx, which is time, vertical and horizontal, is 0.55 seconds. Dx is our question, and Vx is 55 meters per second. That way. V equals d over t. D equals v times t, which is 55 times 0.55, which is 30 meters. So that's how far the arrow actually travels. So the arrow only gets to about right there. Okay, so our real trajectory is more like that. Okay. The second part of the question says, what should the archer do to get her next shot on target? Well, she can do two things. She can either aim the bow so that the arrow flies at an angle, okay, thus giving her a longer time in the air, therefore giving her a longer range, or she can simply fire it faster. A greater Vx, you can see if we were to change 55 to, say, let's double it, so let's say 110. If we did that, we would get 110 times 0.55, which would give us 60.5 meters. So two things, either shoot at an angle, like we have here, or simply shoot it faster, as we have here. An acrobat is launched from a cannon at an angle of 60 degrees above the horizontal. So let's just show that. we'll say that's 60 degrees above the horizontal. The acrobat is caught by a safety net mounted horizontally at the height from which he was initially launched. Suppose the acrobat is launched at a speed of 26 meters per second. So this acrobat's going to go something like that, and it's going to land in some kind of net right there. So A says, how long does it take before he reaches his maximum height? Now, what's his maximum height? Well, that. We'll call it dm. Dm is going to be the maximum height. So dm, we don't know. A says how long, therefore time, we don't know. B, how long does it take in order for him to reach a point halfway back down to the ground? Now, it's a little confusing, but what that means is that from this point right here, so t equals 0, to a point halfway, we'll call that right there, and we'll call that t3. Well, I call that t2. t3 is halfway back down. Okay, so it's going to be the time from t0 to t3. That's going to be the answer to B. Okay, but let's focus on A right now. Now A says time to reach the maximum height. So look at the vertical component only and find that VF, y in this case, will equal 0, of course, because it's going to stop, sort of like this kind of trajectory. As it reaches the top, the VF is 0. It's not traveling upwards anymore. Okay, VI is going to be the vertical component of 26. So it's going to be 26 times sine 60, which equals 22.5. T is the question, and A is going to be negative 9.8 meters per second squared, because we are going to say right and up is positive. Now, what equation can we use? Well, we can use A equals VF minus VI over T. We rearrange T equals VF minus VI over A. You plug your numbers in, 0 minus 22.5 divided by negative 9.8, and we get 2.3 seconds. Now, 2.3 seconds is the time that it gets to right here. So that's going to be T2. We'll call that 2.3 seconds. Okay, so let's move on to part B. B says find dm, find the maximum height. Well, in this case, again, let's list our variables, and we're going to assign both those to be positive. Okay, so we're going to say VI equals, again, 26 sine 60, which is 22.5. VF is equal to 0. Distance is the question, and acceleration is negative 9.8. We use our equation, VF squared equals VI squared plus 2AD. That's 0. That's 22.5 squared. 2 times negative 9.8 times d. Once you do your rearranging, you get a dm equaling 26 meters. Now, consider a fall from this point. Okay, so the object goes up. In this case, the person goes up to here, to dm, right there. And then it starts to fall down. Now, we want to know how long it takes to go from here to here, more or less. So now we're trying to find t1 to t2. We need to find that time. And since the distance traveled, because this is, of course, 26 meters dm, this distance here is only 13 meters. Okay, so let's write again our variables. So distance, the distance that it's going to fall is going to be 13 meters. We know the VI is going to equal to 0. We are now going to change our assigning of positive and negative. Okay, and we can actually do this. So we're going to say down and to the right now is positive to make things easier. VI is 0. Acceleration is now positive 9.8. And time is what we are looking for. So we're going to use the equation d equals VIT plus 1/2 AT squared. 13 equals 0 plus 1/2 9.8 t squared. You do your rearranging, you get t equals 1.6 seconds. Okay? So now we know that t0 to t1 equals 2.3 seconds. t1 to t2 equals 1.6 seconds. Therefore, time total is 2.3 plus 1.6, which is going to equal to 3.9 seconds. And that's your answer. A championship golfer uses a 9-iron to chip a shot right into the cup. If the golf ball is launched at a velocity of 20 meters per second, at a 45-degree angle, so 45-degree angle, and it's going at 20 meters per second above the horizontal. A, how far away was the golfer from the hole when it hit the ball, and what maximum height did the ball achieve? Okay, so we know that the path is going to look something like that. That's going to be dx. That will, of course, be dm, maximum height. And the way this question is phrased, we're saying A, we are looking for dx, and B is going to ask for dm. Obviously, this is going to be the vertical component, and that one's going to be the horizontal component. So let's take a look at A first. Okay, now A is looking for dx. So dx is our question. Tx, we don't know, but we do know Vx. Vx is going to be the horizontal component of our vector. So it's going to be 20 cos 45, which equals to 14.1 meters per second. That way. And don't forget, positive, positive. But now we have two variables, right? We have dx and we have tx. We cannot solve when we have two variables that are missing, so we're going to need to, of course, come back. Okay, well, let's set up our equation. We know v equals d over t. We can do this for later. D is our question. D is going to equal to v times t. We know v is 14.1. Now we've got to find time, and we'll come back to the time. Now our previous, as we have right here, we just plug it in, so we have 2.86. Our distance becomes 40 meters. That way. So that's the answer for A. Okay, and we found the answer to B on the previous page. Okay, so let's move on to the second part of the question. The second part of the question asks us to find dm. So dm is our question. So obviously in this case we need to focus on the vertical component only. Okay? And hopefully through this vertical component we can find t. So dm, vi is going to be the vertical component of our 20. So it's going to be 20 sine 45, which is equal to 14.1 meters per second up. Vf is 0 because at that point it has stopped moving. And acceleration is going to be negative 9.8. We are again going to sign right and up as positive. Now, the easiest equation to use, Vf squared equals Vi squared plus 2AD, 0, 14.1 squared, 2 times negative 9.8, D. You rearrange and you find D equals 10.1 meters. 10.1 meters. We can therefore say that therefore dm equals 10.1 meters. Now, we still need to find T. If we find T to the max height, so we can call this also Tm, if you will, time for the ball to get up to the max height, we will know that T total is going to be 2 times Tm, right? Because as the ball goes up, if you will, like this, that is Tm. That would be, if you will, Td, or T down. So time is going to equal to Tm times 2. Because what comes up, what comes down in the exact same time frame. Okay, so however long it takes to go up, if we double that, that's going to be the time it takes to go up and come down. So again, looking at the vertical, time is the question. Dm is 10.1 meters. Vi is the same, 14.1 meters per second up. And Vf is 0. So let's use the equation. Dm equals 1/2 Vi plus Vf times time. 10.1 equals 1/2 14.1 plus 0 times Tm. And therefore Tm is 1.43 seconds. Now the total time, as we said above, is going to be 2 times that. Okay? So therefore T total is going to be 1.43 times 2, which is going to be 2.86 seconds. Now if we sub that back into our original equation, so let's take a look back at our previous. Now let's plug that back into our other formula from the first page. So we're going to have D equals V times T. V we know is 14.1. Time we now know is 2.86. So we get a total distance of 40 meters. As part of a physics investigation, a student launches a beanbag out of an open window with a velocity of 4.5 meters per second at an angle 25 degrees above the horizontal. So if you will, our buildings like that, this can be our window. There's the launch. Now the launch is only 25 degrees above, and it's 4.5 meters per second. If the window is 12 meters above the ground, 12 meters, how far away from the building must a student's friend stand to catch the beanbag at ground level? Now we know that the trajectory is going to look something like this. Okay. And here's our willing friend waiting to catch the ball. So a couple things to point out. This is going to be max height. Okay. But if you will, there's the horizontal, okay, from the window. So this is going to be now dm. Okay. We are going to assign right and up as positive, as per usual. This guy right here is going to represent our range, or dx. And that's about all we know so far. So if we're looking for the dx, which is really what the question is asking for once you've sort of looked at it a few times. Okay, so dx is our question. Okay. We know vx because vx is going to be a component. Right? It's going to be 4.5 times the cos of 25, which comes out to be 4.08 meters per second. That way. And tx is going to be another unknown. So we can't do this. Okay? As with previous questions, we need to find t first, which we can sub back into this formula right here, and then we can use that to find dx. Okay? So again, let's take a look at the vertical component. Now this gets a little tricky, so let's break it down into a few steps. You can see that I've redrawn the picture. So the first step we're going to do is we're going to find t up, as in t to get to this point right there. Okay, how long does it take to get from here to here? We can call this t0, t1, if you will, and we can call this t2 for later reference. So find t up. How long does it take to get from here, from right here, to right up here, okay, time-wise? So let's again look at the vertical components. Okay, we know that vi is going to be the vertical component of the velocity, which is going to be 4.5 times the sine of 25, which is equal to 1.9 meters per second up. We know that the acceleration is working against the velocity, so it's negative 9.8 meters per second squared. T up is our question, and Vf, as always, is equal to 0 at the very top. So we plug that in. We're going to use the equation A equals Vf minus Vi over T. T, once we've inserted our numbers, is going to equal to, well, I'll draw it out for you here. Vf minus Vi over A, and once we put in our numbers, we get 0.194 seconds. So again, that means for the ball to go up to its peak, so to travel from here to here, it's going to take 0.194 seconds. Okay. Now the second part, let's find dm, because the next component is going to be able to find the time to go from time 1 to time 2. So we need to know the distance. We need to know that distance so we can add it to the 12. Right? Should make sense. So let's find dm. So dm is our question. VI is 0 because it's starting from rest in the horizontal component. Oh, sorry, excuse me. Getting ahead of myself. Sorry. Our VI is still 1.9 because we're trying to find out, excuse me, that distance right there. 1.9 meters per second up. VF is still 0. And time, we just figured out, is 0.194 seconds. So which equation are we going to use? Well, let's use D equals 1 half VI plus VF times T. We get 1 half 0 plus 1.9 times 0.194. And we get 0.184 meters. So that's this distance right here. Okay, DM, 0.184 meters. So now 3 is going to be find time as it drops. As it drops from max height. In other words, find T, T1 to T2. More or less that's what it's saying. Okay, so what do we know? Okay, well, we're looking for T. That is our question. Okay. We know the distance because we just figured out it's 0.184 meters up. So we say 12 plus 0.184. And that gives us 12.2 meters. VI, because it's starting from the top, remember? So since it's starting from the top, the VI in the Y component is 0. And acceleration is 9.8. Now we've changed it, right? We can do this, as I said before. Now we're going to say down and to the right is positive. As long as you assign it at each different divisions of your question, you can change it as you see fit to make it easier for yourself. So let's use the equation. D equals VIT plus 1 half AT squared. 12.2. That's going to be 0. 1 half 9.8 T squared. When you rearrange, collect like terms, solve for T, you end up getting 1.58 seconds. So now the fourth step, we are going to find T total. Find T total. In other words, we're going to find T0 to T1 plus T1 to T2. That's not too difficult. This is 0.194. We just found 1.58, and that gives us 1.77 seconds. Now, finally, we can solve that back into our original equation. Okay, so we know we're trying to find dx. So we'll say, call it number 5. We'll say dx is the question. Tx is 1.77, and Vx, as we've already established, is 4.08. V equals d over t. Distance equals velocity times time. You plug your numbers in, and you get 7.2 meters that way.